talk to you a little bit about Qt. So I'll talk a little bit about some other ways to build GUIs and a little bit about why they're becoming very pervasive. But primarily we'll just kind of dive into a little bit of Qt, just a pretty high level introduction. Then I may bring somebody in towards the end to just give you a little quick demo. I could do a demo, but I think it's better to see it on a little bit more of a real device. So I'm going to have somebody come in and just do a quick demonstration of loading code up and building code up with Qt. So first, I'm going to cover why are there GUIs everywhere? What's the motivation? Which tools are you going to choose to try to create your GUI, to try to match those experiences that are being demanded? A little bit of introduction to Qt itself, the Hello World sort of app, and we'll show just building a little basic application, and then talk a little bit more about the introduction to the overall Qt framework, and then explore some of the examples and give a demo at the end. So all of this demand for different experiences on your embedded devices and can be largely summarized up as the pinch effect, right? So one example here is an engineer stepping up to an oscilloscope and just reflexively starting to pinch, right? I want to zoom in on that signal and just grab it and pinch, and why doesn't that just work? And so we find that these smartphones are dictating the experiences that we're expecting with all of our devices in our everyday life, right? So it used to be the start menu on Windows, but audio go off. So it used to be the start button, and everything sort of followed that paradigm, and Windows. But now it's really those the smartphones experiences that are driving the expectations that consumers have about their products. And this is shown again and again over different experiences, things like haptic feedback, or the physical push buttons, and really we have all this expectation in all of our day-to-day life that our devices are going to behave intuitively with the experiences that we have for things from our phones. We also have this trend for an Internet of Things, right? This is also helping to drive this need for these GUIs, where everything's connected and you're essentially providing web-like experiences and web interconnectivity and presenting data coming from other sources in many more types of environments, a lot more connected experiences, be it in consumer applications in the home or on the go, different accessories, even down to the point of industrial equipment. So what do we want to choose to go try to solve this problem of giving people that experience that they expect, and to be able to fit it into a lot of different markets with a lot of different price requirements, right? There's a lot of different price pressures in these, so we need to find a well-fitted solution. And the ones I want to talk about real quick, there are any number of different GUI building solutions for you. The ones that I just personally think are most interesting and give you some other things fall into a bit of the similar categories are HTML5, or the browser itself as a driver of the GUI. Android, because that's an option that you have or you can use in your embedded devices to directly deliver that smartphone experience. And then Qt. And I've got these ranked here in a bit of an order from the least amount of skill required to get the most basic sort of applications up and running, right? I think anybody with a high school education that's done some any interest in technology whatsoever has written an HTML web page, right? That's pretty darn easy. I'm not insulting anyone. But that's really the really low-hanging fruit, right? And then you see at most universities, students are going and the requirements if they have programming requirements, it's often in Java now. And so maybe they never really learned the type of programming that most of the Linux developers do. It's C in the kernel or C++ in the user space, right? So you get a lot of developers that just never have experience beyond Java. And Android is a really nice fit for them. And it really appeals to a very broad base of people, but a little bit more skill level expected there. Even though there's nice packaged tools, there's still a little bit more of a skill level expected to build an Android application versus just building a web page and a simple interface through web pages. And then there's Qt, right? So again, a little bit more skill required. Although you can program for Android and C, it's just for certain library functions. Most everything's in Java, whereas with Qt, you need to actually use C++ and C-like things. There's also ways to program it in JavaScript with QML, and actually that is a bit of a game changer in terms of the complexity of Qt. It almost gets you the simplicity of building out web pages for your application, but it's giving you more of the performance here of Qt. Because it is C++, right, and not an interpreted or just-in-time sort of compiled language, it is very high performance. If you're looking at different ARM microprocessors, Qt is one that you could practically run well on an ARM 9. So that's plenty powerful enough to run a lot of Qt GUIs. With Android, you'll see more the case that you get the Cortex-A's series of families. If you really want to run Android today, they're releasing on Cortex-A9s and multi-core Cortex-A9s. And then the JavaScript stuff also works really well on that series of processors, but maybe not quite to the same level of performance that an Android app would. So you can see here there's this spectrum of simplicity and performance, and we're going to focus most on the one with Qt, simply because of the fact that it's able to reach the most devices because it requires the least amount of processor resources to run. Just want to think a little bit more about some of the similarities and relationships of how these different environments do different things, right? So if you have system services that you're trying to utilize, or you want it to talk between components at the HTML5 and JavaScript level, and if you're using a back-end server, something like Node.js, or several others if you wanted to use different types of web servers, if you want to do things in Python or Ruby. You have these ability to deal with functions as data comes back to them, right? You're generally dealing with things as network request type of information. You use standards like REST, and you can do things with your web server to talk dbus, and if you're coding natively in JavaScript on your server, you can make dbus requests and get responses back to run your functions using the closure concept. So you just provide callback functions to satisfy the getting information from other applications and other system components. And it's at a very high level of abstraction. Whereas something like Android, I mean, I can definitely imagine some criticism for these types of comparisons. They're not exactly orthogonal, but I think that there's some interest in it. But like the Android world, if you want to provide a service, or you want to consume a service, right, it's all done with these activities and intents, right? So those are also fairly high-level ways but not nearly as high level as just dealing directly with like web services. And then with Qt, there's this concept of signals and slots. So, and with Qt, it's a very regularized thing. Every object, every C++ object, right, has this signal and slot interface to communicate with it. And so that's how all of the objects that you create in Qt communicate. And then what different platforms do these all run on, right? You can run the HTML5 anywhere you have a browser, which is a lot of different platforms. With Android today, you can run it on phones and tablets, but of course with the Android open source project, you have the ability to deploy Android on a lot more devices than just those. And Qt is, it's native C++, but the libraries are implemented for several targets, including Mac, Windows. I have a list later, but there's an enormous number of targets, but it's all built per platform. So let's go through a quick little exercise to see how you might get started doing some Qt development. This is trying to make this a product pitch, promise. But if you were to use TI tools, right, so it's just leveraging the Linux open source tools and the open source Qt libraries and the open source GCC toolchain. But there is a bundled set of libraries and toolchain, delivered in an SDK environment for you, and you would just install the Satara SDK onto your PC running Ubuntu. Ubuntu's required. The expectation here for this SDK is how it's tested, and then simply just source your environment path. Right, so all the environment variables you need in order to utilize the tools from the command line are just in an environment shell script. So if you wanted to do a simple Hello World application, you can just create a directory called Hello World, and this is essentially the structure. You have an application object that you're going to run. You add a label to that object and run, and that's the simple Hello World. And then to build that, well, let's just trying to figure out how much time. I haven't exactly timed this. I don't know exactly how long it's going to take me to do this, but I think I have time to go ahead. And this is Ubuntu running in. It's a really long path. I'll skip that. Hello World isn't, it looks just like what you'd expect. So, you do, when you run and build it, you do Qmake project that gets over, the Qmake ends up in your path. You do Qmake to make your project, you do Qmake to generate your make file. And then you do make to build your application, and that's the typical development flow for a Qt application. Okay, we're just going to shrink this. So inside of here, is a simple example application. So in the Qt library itself, there's over 300 demo and example applications, and all those are shipped with the SDK. They come directly from the Qt SDK, but it is not supported as part of the TI product. there's a wide variety of applications in there, and it's pretty straightforward. If you wanted to build those, you just go under the directory where the demos are and run qmake and make. I will show building one example application, and this one blends a bit of the HTML5 and the Qt world, and something that's a bit of a rapid GUI application development environment. And it's shipped as a demo with the TI SDK, and it's a push-button application launcher. And it's built up of menus served up as an HTML file, and then the server actually parses out .desktop files and icons and creates entries in the HTML file for creating the application launcher. And it's all done styled and fit on the page using just cascading style sheets as a web object in Qt, right? So Qt actually includes something called WebKit, so you can instantiate a web browser into your application, and that's how this is simply done. And we've got entries for adding all the individual applications, but now this is actually done with .desktop files. What's interesting about this, if you want to run some of the applications, the browser is slightly modified in order to capture all the standard in and standard out of the applications that you're running. So when you invoke one of the applications, you'll get the standard out right there directly in your browser. It captures and streams that over. So if we want to build that application, it's as simple as stepping over into the directory, go into matrix GUI browser, qmake, make. So not a whole lot to that. Qt also provides something called Qt Creator. So that's a GUI that you can use to build your applications. And this is also where you'll get you get the environment to draw all the buttons on your screen, as well as to do things like create the applications with Qt Quick. So I've got running here just a quick view here of Qt Creator. So you can see our Hello World application. And Hello World, right? So this one was created using QML though. So this Qt Quick project. So if you want to create that, you simply open up, you just do create project, Qt Quick project, Qt Quick application, you choose it, you give it a name. Say that I want to run it on the desktop here. Tie it into Qt to get version control. And I've got a new project. Oh, I just hit it. There it is. Where'd it go? So again, hello world. Now this can all be edited, the layout. So you can see here, this is how we can go and add new buttons. We can add text areas. So this is a rather high-level, simple way to create applications. So in addition to Qt Creator, this is the first GUI screen for that big collection of demos that are shipped with Qt. You can see I've built that here, and you can go through here and you'll have different animation frameworks, layouts. This is the greatest way to sort of explore what some of the obvious capabilities are of the Qt library and get you some really great examples on where to start. You see things here like you've got WebKit and browsers that you can implement, different layout tools, border-based layouts, or so there's. But it's not just limited to things like GUI actions. There's also in Qt, there's networking, there's database. So it's really everything that you need to build your end application. So that's the quick view. We'll dive a little bit deeper now. So it's a cross-platform UI framework supported by at least these different platforms, and it's growing, and there's more all the time. It goes all the way back to days like Amiga and OS/2 and Open Solaris. So there's really aren't many targets that you're going to be developing for that you really that you're not going to be able to find support for. And of course, there's embedded Linux. There's two different. Well, we'll get to that. So the types of frameworks, there's XML APIs in there, scripting, database, benchmarking of fonts. There's 3D support with OpenGL. There's multimedia support. There's support for multiple language, so dealing with internationalization and build support. And a lot of the applications that you use today were built using Qt. If you're using the KDE desktop, that's built using Qt. The VLC media player was built using Qt. Skype, Adobe Photoshop album, even things like Google Earth. And then the code base for the web browser is WebKit, and that's shared with a lot of the browsers that you've probably interacted with, be it Chrome, the iPhone, iOS browser was based on WebKit, Safari for the desktop. Things like the Amazon Kindle utilize WebKit, and our little Matrix GUI example. The licensing for Qt, I think, is an interesting thing. So there's actually 3 different licenses that you can work from. So there's a commercial license that you can use. There's an LGPL license and a GPL v3. So this GPL 2 license was added most recently, and this is, I think, probably the most popular choice now, right? It's a very, very popular choice now because it allows you to make proprietary applications, but the requirement here is that if you're making it proprietary, you have to dynamically link, otherwise it's subject to the LGPL. A lot of the folks in this room might be perfectly happy though just using the GPL3 version and keeping everything open and all the derived applications open as well. And of course, with the proprietary version, you can actually change and customize the Qt library itself and not have to redistribute. So here's the URLs if you wanted to go and fetch the Qt SDK for some various platforms, and includes a lot of different components, tools for building your applications. The typical build flow is to have Qt, build Qt for your target. A lot of targets provide a lot of SDK or even evaluation modules or chip vendors, or will provide Qt built for that particular target already. You create your project files, you design your UI with all the buttons and everything which way you want it to look, and then you start going in and adding event handlers and to do the interactions with the user. Then finally add the real functional application code. How this looks on Linux, there's 2 different approaches that you can take to getting the menuing system, or the GUI out to your screen. You can use X11, or you can use Qt embedded, which will write directly to the frame buffers. So you have those two options. There's a slight performance advantage in most cases for using Qt embedded and using just a direct output to the frame buffer. There is some support for sharing the frame buffer between Qt applications through a windowing server, but you can directly interact with touch screens and mice and everything just directly over that frame buffer interface. There's a ton of widgets that you can use to create your GUI, your interface, different layouts for elements on the screen, different things that you can fill them with, just about every sort of design component that you might want to create your GUI. And this is another one of the example applications that's included with the, that's a TI example. It's just a little bit of a oscilloscope or spectrum analyzer demo. And this is doing FFT analysis and showing the signal on top and showing the FFT analysis on the bottom. There's when you want to do painting, there's low-level interface so you're not just stuck with the GUI elements, right? You can do all your drawing elements as well. So you can do lines and arcs and ellipses and polygons. And the paint engine also gives you the ability to tie in to 3D graphics. So there's a GL widget. So you can this is always going to be a 2D surface. When you want to do like a 3D user interface of some kind, what you're going to do is create this GL widget and put it on the screen where you want it, and then you have the 3D rendering in there. And essentially you just use the OpenGL or OpenGLES calls the same as you would if you were writing it not within the Qt environment, if you're just writing directly. But what you have the extra advantage of here is that you can create surfaces within that 3D space that you fill using Qt. So you can actually create 3D UIs that you fill the surfaces with Qt and then render them in 3D. So you also have so you build up from the graphics view framework. Gives you a mechanism for displaying the contents of a graphic scene. You have the idea of depth, so you can overlay different graphics on top of each other. And then you can take that and render it with GL. So the signals and slot concept, this is actually a really powerful feature of Qt because all the Qt objects have this. Since it's a really nice mechanism for communicating. It's kind of like function pointers, but it gives you really a whole lot more capability because it includes all the things that you need to do the argument checks. So that you know that the types that you're passing between the different functions, the objects, are valid, right? So it allows you to kind of flexibly move around and access the object from different places, but know that you're still doing it in a way that's valid. So you can do things like have separate threads that do some time-critical functions and use this signals and slots feature to do screen updates that across different threads. So that's an absolutely critical aspect of if you're trying to have a sophisticated GUI app, is if you're trying to do something like the example we had up on the screen before where we're drawing this oscilloscope. You don't want your main event loop blocked by the data that you're dumping for the updates on the screen or for the signal, the wave pattern, right? So you want to still be able to asynchronously go and do the event loop for handling the buttons. So when you create your object, you tell it what signals and slots that your object provides. And so those are all different methods that get exposed to the other objects within your application. So this is just the sort of base syntax for that. And this is essentially how the pipeline works, where you've got the Qt application where you're just using Qt embedded. You use Qt Painter, Qt Paint Engine. It goes through the EGL in parallel to access to write into the frame buffer for doing the 3D graphics, or the DirectFB for 2D graphics. So this, I mentioned there is this way to share the screen among Qt applications for directly accessing frame buffer. That's exclusive to Qt embedded, although there is a virtual frame buffer driver that you can use to run Qt applications written for accessing the frame buffer, or written with Qt embedded to get those to work under X. But that's so because of the QWS engine supports output through the Linux frame buffer directly, this virtual FB that you can run under X11, and different things like, of course, VNC, where you're streaming the frame buffer across the network. And I don't want to turn this into any sort of advertisement, so I'm not going to go over any other components within our SDK that we provide.
My name is Roman Pokshevka. You say it much more easily than you write it. I'm actually working for KDAB, which is we're a local company. Our office is right across the street, as a matter of fact. And we are a long-term Qt software engineer company. We've been basically, we've existed for over 12 years, and we've kind of grew together with Qt before it was even Nokia. At the time it was Trolltech. So I just got the opportunity here to offer a quick demo of basically, showing first. Did you have the opportunity to do a demo of some Qml apps? Did you show some of that?
I just ran a hello world QML.
Okay, you ran. So I'm just going to show a couple of examples locally here on the machine, showing the different capabilities of QML, and then I'm going to show. I brought a little tablet with me here, which is a OMAP 3 based tablet, and yeah. And so I'm just going to show you how, using Qt Creator, you can go in a matter of minutes from running your QML app on the desktop to running it on the tablet, all within Qt Creator, including deployment and running remotely. So I'm going to move to my Qt Creator window here. So first, so I have these few examples running. So this is now a few apps. This is a photo viewer running QML. It actually fetches. The reason why you don't see the things loading here is this. It actually fetches the photos online. All right. It uses Flickr for that. Unfortunately, I realized I didn't set up the network for that one. But I have a few others. I have this one, which some of you may be familiar with. This is an example of a small application that was written actually entirely in QML in this one. And so it shows that you have support for easy support for animations, nice effects, including particles. You have all the elements of normal user interfaces, touch input, including multi-touch input, but as well as keyboard. Okay, simple logic can be implemented using JavaScript, and if you need to do more heavy lifting, in that case you would use C++. Now let's have a try at running that application on the tablet. So Qt Creator comes with all the tools to let you connect to generic Linux devices. In that case, it uses a standard SSH connection. So here, I'm just testing a connection to the tablet, which I have set up previously. And then the next step will be, so let's cancel that. So as we did the same example, we can just reuse that example here. Run it. So let me just find the same game project. Here it is. I'm going to make that the current project. And now here what I'm going to do is I'm going to switch. I have the possibility of switching Qt versions, so I can build multiple versions of Qt in parallel. So in that case, here I'm going to switch to a pre-built embedded version of Qt. And I'm going to run the build. So this one, as you can see, uses the Angstrom so the sorcery G++ toolchain that I've used with OpenEmbedded. So the Qt version that I have here, this is Qt 4.8, is Qt 4.8 embedded, which I've built as part of Qt embedded. And I've just imported the toolchain as part of the in Qt Creator. Okay? So now the next step is just specifying that I don't want to run my app locally, but I want it to be deployed remotely to the tablet. Okay? And then specify also, instead of running it locally, I want it to be run remotely. Okay. So I'm adding a couple of arguments here, which is to specify I want to use the Linux FB frame buffer platform plugin, and I want to have access to the touchscreen via Linux input mouse plugin, okay, which is actually going to be connected to the touchscreen. Okay, so that one is fine. It usually does that for the first time. All right. And let's see here. Oh, it's missing a part. Okay, you can see at least on the tablet now we have the base application. It failed to upload a file. My bad for that. I would gladly fix that during the next minutes. Anyway, we're running out of time. Anyway, feel free, I'll be staying there. If you want to come and have a look and play with it, I'll just upload the missing file and you can see the thing running in here. So here what we have done in a nutshell is going from the local x86 build of Qt running locally on our machine to cross-compiling using a same Qt but built for ARM, open embedded, cross-compiling and then remote deploying the application on our tablet. And as you can see, this was all, the initial setup is only a few minutes. You specify the SSH connection parameters to your tablet, and then you just specify also a version of Qt that you want to use for building. The whole cross-compiling part is 99% transparent to you. It's done through the Qmake tool, which takes care of selecting the right toolchain, selecting the right build parameters, and so on. Okay?